This is Kavita S., working as Assistant Professor in MIT Academy of Engineering, Pune. This video is about the introduction to distributed systems and its characteristics and features. The topics discussed in this video are 1. What is a distributed system? Examples of distributed systems, common characteristics, and different types of transparencies. So what is distributed system? A distributed system is a system whose components are located on different networked computers which communicate and coordinate their actions by passing messages to one another. A distributed system can be considered as a collection of autonomous systems that are physically separated but are connected by a centralized computer network that is equipped with distributed software. So, why do we need distributed systems? Assume that you are a retail store owner and you want to develop an e-commerce site. Currently, you are running a server with standard LAMP environment. L stands for Linux operating system, A for Apache web server, M for MySQL database, and P is a PHP. As business grows, there will be an increase in sales and traffic. So what you will be doing? So you have to migrate to a dedicated e-commerce platform which can handle increased traffic sales, inventory management, order processing, and reporting. At the same time, the system should have optimized performance and the system should be scalable for handling increase in traffic. This includes upgrading the server resources also. The customer expectation will be enhanced shopping experience. So you need to add filters and comparison tools in the e-commerce site. At the same time, reporting and analytics features also should be included in the e-commerce site. So there exists the need for scaling the system. So scalability is the property of a system to handle a growing amount of work by adding resources to the system. Scalability can be of two types, vertical scaling and horizontal scaling. Vertical means adding more resources to the single node and horizontal means adding more nodes in the system. When you are scaling, the system must be fault tolerant and system should give low latency. Fault tolerance means even if a node fails, the other nodes should be working. The entire system should not be down. Latency refers to the time for a network communication or data processing. So the system should have low latency. So from all this, we have come to know that the main characteristics of distributed system are multiple autonomous components. Components means it can be network infrastructure, it can be distributed data storage, distributed techniques for distributed data recovery, techniques for the fault tolerance, etc. Components are not shared by all the users. Software runs in concurrent processes on different processors. Then the system will have multiple points of control and multiple points of failure may also be there in the system. The examples of distributed system are local area network, database management system, automatic teller machine, internet, mobile and ubiquitous computing. Consider the example of database management system. Different client applications want to access and update shared data in the database. Client applications can be banking system applications, airline ticket reservation system, etc. The database is physically distributed over several processors to take advantage of local data access for increased performance. Data may be replicated also to reduce the impact of failures. Each processor runs a database monitor that implements the mapping between the database seen by the clients and the physical database stored on different processors. Database monitors have to cooperate with each other to implement client accesses to remote data, updates of replicated data, and concurrency control. Physical distribution of data is therefore transparent to clients. So when we are constructing a distributed system, there can be heterogeneity, there should be openness, security, scalability, failure handling, concurrency, and transparency. So what is heterogeneity? Heterogeneity refers to variety and differences in networks, computer hardware, operating systems, programming languages, and implementations by different developers. There are middleware or software layers to provide programming abstraction as well as masking the heterogeneity of the underlying networks, hardware, OS, and programming languages. Example, Corba. Mobile code to refer to code that can be sent from one computer to another and run at the destination. Example, Java applets and Java virtual machine. Openness. Openness is concerned with extensions and improvements of distributed systems. Detailed interfaces of components need to be published. New components have to be integrated with existing components. Differences in data representation of interface types on different processors have to be resolved. Security. In a distributed system, clients send requests to access data managed by servers and resources in the network. For example, doctors requesting records from hospitals, user purchasing products through the e-commerce site. So for all these type of applications, security, privacy, and authentication are very important. Concealing the contents of messages comes under security and privacy, and identifying the remote user or other agent correctly comes under authentication. So some challenges are there under security. The challenges are denial of service attack and security of mobile code. Scalability. Scalability refers to the adaptation of the distributed system to accommodate more users. And at the same time, response will be faster. Usually, the systems are scaled by adding more faster processors. So when you are scaling the system, already existing components need not be changed. Okay. So while designing the components, you have to design in such a way that the components can be scaled. Failure handling or fault tolerance. Faults can occur at all levels, at the network level, at the hardware level, and the software level. System must be capable of handling faults. So distributed systems must be always available, even at the low level, that is at the hardware, software, and network level. Fault tolerance is achieved by recovery and redundancy. Concurrency. Components in distributed systems are executed in concurrent processes. Components access and update shared resources. Integrity of the system may be violated if concurrent updates are not coordinated. So if the concurrent updates are not coordinated, results may be loss in updates and inconsistent analysis. Transparency. Distributed systems should be perceived by users and application programmers as a whole, rather than as a collection of cooperating components. There are different types of transparencies. The transparencies are access transparency, enables local and remote information objects to be accessed using identical operations. Example, SQL queries, navigation in the web, and NFS. File operations in NFS. Location transparency enables information objects to be accessed without knowledge of their location. Again, file operations in NFS, pages in the web, and tables in the distributed databases are the examples. Concurrency transparency enables several processes to operate concurrently using shared information objects without interference between them. Examples, automatic teller machine, database management systems, and NFS. Replication transparency allows multiple instances of information objects to be used to increase reliability and performance without knowledge of replicas by users or application programs. Example, distributed database management system and mirroring web pages. Failure transparency enables the concealment of faults, allows users and applications to complete their task despite failure of other components. Example, database management system. Mobility transparency allows the movement of information objects within a system without affecting the operations of users or application programs. Example, NFS and web pages. Performance transparency allows the system to be reconfigured to improve performance as the loads vary. Example, distributed mix. Scaling transparency allows the system and applications to expand in scale without changing the system structure or the application algorithms. Example, World Wide Web and distributed database. So in this video, we have discussed about the definition of the distributed system, the characteristics of the distributed systems, and the different forms of transparency. These are the references which are referred for the contents of this introduction video.